So now that we understand how to address the variety of screen sizes and densities out there, we can get into how we go about constructing your user interface. As you'll remember from Android fundamentals, your UI is a nested tree that we call the view hierarchy. Now this tree defines the entire structure of UI from the root view group all the way down to the leaf views such as text, buttons or images. Now every single thing you see on the screen in your app is a view somewhere in this hierarchy. You can define your UI either by creating these objects in code or by declaring your layout in an XML file. Now we very much prefer the latter approach as it allows you to separate the presentation from the app's behavior. Each element in your UI will have a number of parameters associated with it. Some are common and must be provided for all views, such as its width, height, or location on the screen. Other parameters are specific to a particular view, such as a button will have parameters for its background and the text to display. Let's dive in and see how the elements are sized and placed on the screen. If you've ever dabbled with web development, then you'll be familiar with the box model in CSS layouts. If you haven't, let's take a quick tour. Now all UI elements in Android take up a rectangular space equal to the minimum rectangle needed to enclose the object. We call this the content bounds. Take this avatar placeholder image for example. Even though the image is a circle, its content bounds are this enclosing rectangle. Well, that's not entirely accurate. The object's bounds also include any padding, that is, any space that's considered to be part of the object that pushes its bounds outwards. So, in our example, the bounds would be equal to the contents area plus any padding applied to it. When positioning an element relative to other elements, you might also want to leave some space between them. This is where we can use margins to add extra space between objects that critically isn't considered to be part of the element. So we've seen how both padding and margins can be used to add extra space around an element, so you might be wondering when to use one or the other, or perhaps even a combination of both. Now the key thing to remember is that if you want the space to be part of the object, then you should use padding. And if you don't want it to be part of the object, then you should use margin. So when do you want it to be part of the object becomes the question. The answer is if you want the touchable area or the background of the object to be enlarged, then use padding, otherwise use margin. So in our example, if we want this avatar to be clickable with a nice big touch target, but we don't want any touch highlight to extend too far towards the other items, we could use a combination of padding around the element to enlarge the touch area, and then margin between the elements to separate them out without that being part of the clickable zone. For those familiar with the web box model, notice that there is no concept of borders. While you can still apply borders, these are typically achieved using background images. So now that you know how individual UI elements are sized, let's talk about how to start arranging them together. Let's have a quick refresher on what you learnt in Android Fundamentals 1 about the core layout managers, like frame layout, linear layout, and relative layout. Now remember, a frame layout arranges the views inside it one on top of each other, and each view can have a gravity or stretch to fill the width or height of the parent frame layout. So frame layouts are a great way to display overlapping content. A linear layout arranges its children in a single direction. For example, a vertical linear layout arranges its children from top to bottom. Linear layout is one of the most useful layouts to have in your toolbox. You can create pretty much any layout with it. Be careful though not to over-rely on this, as another layout might actually be a more efficient way to create the desired effect. A relative layout arranges its child views relative to each other or to its bounds. So, for example, a field can align to the top left or top right or to the bottom edge of the relative layout. While relative layout can be powerful, it also has some performance implications, so be wary of using this layout, especially near the root of your hierarchy. A grid layout arranges its children in a grid. Shocker. When each child has a given row or column within that grid, they can be arranged automatically in any direction and now have a weight property in order to fill a column or row. Grid layout is a great way if you want to align content along multiple axes, such as vertically and horizontally at the same time in a grid, which would be hard to achieve with a different nested layout manager. A scroll view is a very simple view which holds one single child that allows you to scroll its contents either up or down. In Android Fundamentals, we also touched on List View and its newer cousins Recycler View and View Pager, and how it dynamically uses a small number of child views to present a small window into a larger collection. List View and Recycler View let you scroll through a list of items, while View Pager lets you horizontally page through individual items. To understand when to use a particular view group, let's take a look at some examples of real-world screens and talk about how you would build them. After that, we'll show you a quiz and ask you, yes, you, to apply layouts to build up a relatively complex UI.